Hello everyone, this video is on solving systems using inverse matrices. So the first thing we want to talk about is what is an inverse? Inverse in mathematics, right, refers to the opposite of another operation. So if we have addition, the inverse operation of addition is subtraction. The inverse operation of multiplication is division. And anytime we have the multiplicative inverse or reciprocal of a number, it is denoted by 1 over x, which can be rewritten using exponents as x to the negative 1. If I was to go and solve in example 1 this equation, first thing I would do is divide both sides by 4 and x would equal 6. If I used the multiplicative inverse, right, if I have 4x equals 24, if I multiply by the inverse of 4, so multiplicative inverse, right? 4 to the negative 1 is the same as 1/4 times 4x equals 1/4 times 24. Well, 1/4 times 4 is just going to give me x, which is equal to, this would become 24 over 4, which is 6. So using the multiplicative inverse gives you the same exact answer. Now we use this idea with matrices, right? So if I'm giving you matrix A, which is A, B, C, D, right? Those are your elements. So now the inverse of this matrix would be denoted by A to the negative 1, which is 1 over the determinant. Remember those straight bars, right, tell you the determinant of A. Then what you look at is if I take A and D, flip-flop their positions, then I take the opposite of C, right, and the opposite of B. And then I basically use scalar multiplication with this. Okay, now let's look at an example here. If I wanted to find the inverse of matrix A here, the first thing I'm going to do is find the determinant of A. So I know that's going to be 3 times 5 minus 2 times 8. So all I did was multiply these, and subtract. That would give you 15 minus 16, which is negative 1. So the inverse matrix of A would be 1 over the determinant of A was negative 1 times, I'm going to flip-flop to 3 and 5. So that becomes 5. That becomes 3. And then I take the opposite of 2, which is negative 2, the opposite of 8, which is negative 8, and now I'm going to scalar multiply. So that becomes basically, this is negative 1. So negative 1 times 5 is negative 5. Negative 1 times negative 8 is 8. Negative 1 times negative 2 is 2. Negative 1 times 3 is negative 3. And this would be the inverse of matrix A. Now the second one, right? Same process, guys. Once you know how to do one, they're all the same. I start out by finding the determinant of A, which is, right, going to be 6 times 4, which is 24, minus 2 times 1 is 2. So the determinant of A is 22. So now the inverse is 1 over the determinant of A, which is 22. Then I flip-flop the 4 and 6, so this becomes 4, this becomes 6. Then I take the opposite of 2, which is negative 2, the opposite of 1, which is negative 1, and now I scalar multiply. I'm going to multiply everything in that matrix by 1 over 22. So 1 over 22 times 4 would just be 4 over 22. Which technically can reduce to 2 over 11. So 2 11ths. The next one, 1 over 22 times negative 1 would just be negative 1 over 22. 1 over 22 times negative 2 would give you negative 2 over 22, which is negative 1 over 11. And the last one would be 1 over 22 times 6, which is 6 over 22, and that reduces to 3 over 11. This would be the inverse of that matrix. Okay, I know it looks weird because it's got fractions, but we have to get used to that. So now, here's the thing. The next example leads us to the importance of these inverse matrices. What I'm going to do is I'm going to take matrix A and multiply it by the inverse of A. So they actually already found the inverse for you. So if I took and I multiplied 2, negative 1, negative 7, 4 by 4, 1, 7, 2, okay, what I'm going to notice, if you remember doing this, 2 times 4 is going to give me 8. So you would get 8 plus, right? Remember, it's 2 times 4 and negative 7 times 1, right? We would get that. Then the next one would be 2 times 7, which is 14, plus negative 7 times 2, which is negative 14. Negative 1 times 4 would give you negative 4, plus 4 times 1 is 4. Then negative 1 times 7 is negative 7. 4 times 2 is plus 8. And if I simplify this, what I get is 8 plus negative 7 is 1. 14 plus negative 14 is 0. Negative 4 plus 4 is 0. Negative 7 plus 8 is 1. This is a special type of matrix, okay? We're going to talk about it down below here. So an identity matrix is a matrix with 1 on the main diagonal and zeros everywhere else. So an identity matrix would be 1, for a 2 by 2 matrix would be 1, 0, 0, 1. And if I look, the main diagonal here has 1s. If I had a 3 by 3 matrix, it would be 1, 0, 0, 0, 1, 0, 0, 0, 1. And if I look at my main diagonal here, they're 1s and everything else is zeros. So anytime you multiply, right? Anytime you multiply a matrix by its inverse, right? A matrix times the inverse of the matrix equals the identity matrix. And that's something very important to know because it's going to help us with the solving process. So if I were to multiply these two matrices, 1 times x is x plus 0 times y is 0. Then 0 times x is 0. 1 times y is y. And if you look, if I take the identity matrix and multiply it by this matrix, I end up with x, y, like this. Okay, now what does this all mean? Well, we can solve these systems using inverse matrices by writing the equations in standard form. Okay, then you're going to write the system as a matrix equation. So you have the coefficient of all your variables will be one matrix. The variable matrix will be, right, the matrix built with your variables in it, then equals the constant matrix. And we'll talk about this a little bit more when we get to an example. Then all we do is multiply both sides by the inverse of the matrix. So here's the thing. The first matrix, the coefficient matrix, is going to be, if you don't have a number in front, it's a 1, right? So what we're going to do is take these coefficients and write a matrix. So 2, -3, 1, 4 times my variable matrix is just x, y equals my constant matrix is just going to be these two numbers, 19 and -7. So now all I'm going to do, right, is basically what I'm doing is I'm dividing by this matrix, but dividing by the matrix is the same as multiplying by the inverse of the matrix. So we're going to say xy is equal to, right, the inverse of that matrix times the constant matrix. But now I have to go and find the inverse of that matrix, right? So to find the inverse of the matrix, the determinant of the matrix is 2 times 4 is 8 minus -3 times 1 is -3. Gives you 8 plus 3, which is 11. Now, I'm going to do 1 over the determinant times, I'm going to basically flip-flop the 4 and a 2. So 4, 2, and then the opposite of 1 is -1. Opposite of -3 is 3. So that would give me 4 over 11, 3 over 11, -1 over 11, and 2 over 11. This would be your inverse matrix. So basically, xy equals that matrix, 4 elevenths, 3 elevenths, -1 11th, and 2 11th times 19 and -7. So now all I have to do is multiply these together. So to multiply these together, I'm going to do 4 elevenths times 19, right? And that's going to give me 76 over 11 plus 3 elevenths times -7 is going to give me -21 over 11. Then the next one would be -19, right? So -1 11th times 19 is -19 over 11, plus 2 elevenths times -7 would be -14 elevenths. And if I simplify this, I would get 55 over 11 and then -33 over 11. And that tells me xy is equal to 55 divided by 11 is 5. -33 divided by 11 is -3, which now, how do I gather my solution? X would equal 5, y would equal -3. And that would be the solution to this system. And we are done. So let's try one more example here using the same thing. So the first thing I'm going to do is write my coefficient matrix. So we're going to have 4, 3, 1, 5 times my variable matrix. My variables are x and y equals my constant matrix, 10, -1. So now, with this, the first thing I'm going to do is find the inverse of this matrix. So the determinant of that matrix, right? I'm going to say the determinant of the coefficient matrix is equal to 4 times 5 is 20 minus 3 times 1 is 3. That is going to give you 17. So now, the inverse of the matrix of the coefficient matrix is going to be 1 over 17 times, flip-flop the 4 and 5. So 5, 4, opposite of 3 is negative 3, opposite of 1 is negative 1. And now that gives me 5 over 17, negative 3 over 17, negative 1 over 17, and 4 over 17. So that is the inverse. So now the solution to this matrix would be xy equals that matrix, so 5 17ths, negative 3 17ths, negative 1 17th, 4 17ths, times the matrix 10, negative 1. So now all I'm going to do is multiply these matrices. 5 17ths times 10 is going to give me 50 over 17, plus negative 1 times negative 1 is 1 over 17. Then negative 3 17ths times 10 is going to give you negative 30 over 17, plus 4 times negative 1 is negative 4 over 17. And if I simplify this, I would get 51 over 17, and then negative 34 over 17, which would give you the solution. 51 divided by 17 is 3. Negative 34 divided by 17 is negative 2. So my ordered pair solution would be 3, negative 2. All right, go ahead, try the homework, and let me know if you have any questions.